It has one of the largest collections of coins in the world from all periods and cultures. Even things, basically anything that's any kind of object that has currency. So it could be bus tokens or poker chips or anything like that. But the society is especially strong in ancient coinage. There are tens of thousands of Roman coins and something like close to 100,000 Greek coins, I think, between 80 and 100,000 Greek coins. So it's one of the largest in the world. So I won't profess to be an expert on SPARQL, but I've been using it for a few years now, and I know how to do the queries that are useful for my own projects, but I certainly am not an expert on all the intricacies of the language because it is quite complex. So what I'm going to do first is provide you with some URLs to play around with. The first one is Online Coins of the Roman Empire, which is a recent, we've been working on it for 2 years, and a few months ago the NEH gave us a substantial sum of money to finish the project over the next few years. It is a corpus of all the Roman imperial typologies of coins that were ever issued, from starting with Augustus at about 30 BC and terminating at about AD 500. So about 40,000 to 50,000 typologies of coins. The second project is still in the prototype phase. It should be out in production in the next month or two. It's functionally the same as the first project, but it's Roman Republican coins as opposed to imperial coins. And we actually have more coins in that project at the moment, and not just from our institution, but also almost 15,000 coins from the British Museum and a few other museums. The third link is numisma.org, which we have been working on in collaboration with a number of other European partners. It is a linked data thesaurus for the concepts of numismatics. And as you might guess, the leaning at the moment is on Greek and Roman coins, but we do hope to expand to include all of the concepts necessary for all the other periods and cultures of coins. Fourth link is Google Fusion tables. So as I go through this presentation, I'm going to do a lot of SPARQL queries. And some of the results we'll throw into Google Fusion tables so you can get some sort of hands-on experience in creating maps or tables with the queries of our endpoint on numisma.org. And finally, this slideshow is available. I put the PDF on Dropbox, so hopefully you can download it, and that'll be the easiest way to copy and paste the queries. And then plug them right into Numisma and play around with it yourself. So first of all, what is a coin type? A coin type is a conceptual object. It's an intellectual object. It's the idea of an ideal. Yes? Oh, okay. A coin type is an ideal of a typology, and it consists of other typological attributes. So a coin type has a material. It was minted at a certain place. It says something on the front and back of the coin. It has iconography on the front and back. It was issued by some sort of authority, whether a ruler or a state, a nation state, something like that. And it has a denomination and a few other typological facets. Has everybody got the... okay. Okay, so a coin type consists of all those typological attributes that I discussed before. And on numisma.org, each of these concepts is defined with a URI. And if you go to that URI, you can get some human-readable information back, but there's also machine-readable RDF that you can get, RDF XML or Turtle or JSON LD. So each of these attributes corresponds to this type. So it's a silver coin. It was struck as a manufacture process. It was minted in Emerita, which is in modern Spain. It's a denarius, which is a type of Roman coin. And the person responsible for issuing the coin is the Emperor Augustus. And it says certain things on the obverse and reverse of the coin and has iconography. So ochre functions by having URIs for each type of coin. So at the moment we have all of the types through about 240 AD, so we're more than halfway through at this point. So each type has a URI, and there's machine-readable and human-readable information available at each URI. And what we want to do is connect that concept of a type to physical specimens of a coin, which are contained in various museum collections or archaeological databases. So we have some coins from the British Museum and the American Numismatic Society, but we have also information about the type as it was found in a coin hoard, which is by definition 3 or more coins found in a particular stratigraphic layer archaeologically. So coins can have, 5, or a hoard can have 5 coins in it, or it can have 50, 100, 50 or 100,000 coins, 50,000 coins or 100,000 coins. They can get really large. And so even though the hoard information might not contain physical attributes or photographs about the coin, it does contain geographic information, which is really important to researchers who want to do a study on coin circulation over time and space. And so first I'll go through and take you on a bit of a tour through ochre, online coins of the Roman Empire, presuming that it works, I guess. Has the internet gone down in this room?
I just pulled it up, so it is working.
It is working.
Let me disconnect the Wi-Fi and reconnect it, I guess.
The internet knew you were doing it.
Right. So, as we browse through this collection, you'll see that there's a lot of SPARQL happening under here, but you wouldn't notice it because it's so seamlessly integrated into the user interface of the application. So all of these images that you get and the amount of coins or the number of hoards that you get are delivered by SPARQL. If you click on this link, it will load the page with the typological description. It will also load a map which contains find spots for a coin and hoards. So this particular coin was also found in France sometime in the 15 BC or 14 BC or something like that. And there are examples of the coin in different museums, the British Museum in Berlin and American Numismatic Society. So basically I think SPARQL is really effective as a sort of an underneath layer in the back end where you can build tools on top of it to do really cool things in a user interface. But I honestly have no data on how many researchers actually come to numisma.org and do their own queries on the data. I would like to know if people are using it, but unfortunately we don't really have very good documentation on how to use the system. So if you go to numisma.org and go to the SPARQL endpoint, we have some example queries that you can put in, but we haven't really documented the data model that we're using and what properties we're using and what ontologies that we're using. But we plan to do that pretty soon as we release the new version of Numisma. So to get back to the presentation, what I'll do in this demonstration is take you through the really basics of SPARQL and the syntax, dealing with numbers, using filters, different types of functions like average, optional matches, merging queries with union, performing geographic queries, and then plugging some of those things into Google Fusion tables to do visualizations. So the basic component of a SPARQL query, and we've seen some before, but this is the most basic SPARQL query that you can perform. And I have put a limit of 100 on here, so you can copy and paste this into the Numisma and do a query, but please don't do it without the limit, because there are a lot of triples in it right now, so I don't know how it will react.
How many?
I don't even know. But
What's the limit? Find out.
1.1 million.
Okay.
1.1 million.
Okay. So there are prefixes, which I'll discuss later. So you have a list of prefixes, a select statement where you can select the variables that you want to extract, or you can use an asterisk if you want to just get all of the variables that you've put into your query. The query itself, this is the subject, the predicate, and the object, which I'll talk about in the next slide. And then an optional limit if you'd like to put one. So what is the SPO that we've seen a few times so far? So the S is the subject, and the P is predicate, and O is object. And this is the basic premise of linked data, where you have a triple, where everything has a subject, which is a URI. A predicate is always also a URI, and an object could be a literal string or a number, or it could be another URI. So this basic query that I've put on the screen here will get something called a label, a variable called a label, from numisma.org/id/Rome, the URI. It will get this URI here, which terminates with pref label, and then it will call that variable label. So you should get a list of labels back from the Rome ID. And you can express this in a much more abbreviated fashion by using something called a prefix. So a prefix is basically a short collection of characters or numbers followed by a colon. And that short collection of characters or numbers corresponds to a URI. So you can shorten those longer URIs that you saw in the previous frame to nm:/Rome, which is the prefix for all of the IDs in the Numisma. Scos pref label, which is a property or predicate from the Scos ontology, which is a very useful ontology for representing Thesauri. So suppose we want to increase the complexity of the query, and we want to get the label, a type of the URI, a field, which is the field of numismatics, which in our definition could be Greek numismatics or Roman or medieval or Islamic or whatever. And we want to get the latitude and the longitude. So I will copy and paste this into the SPARQL endpoint. And I will change the output to text just to get something that I can show on the screen. And so what this does is it simply gets us all of the labels for this URI, which is a mint. It's part of Roman numismatics, and it has a latitude and a longitude. And there are so many lines, even though the lat and lon and the other things are redundant, because it simply provides a line for each individual label in this sequence. So Rome, in fact, has many different languages and many labels in different languages. So we can shorten this query a little bit by using a semicolon to break the query down a little bit. And so the query that you see below is identical to the same one in functionality, where instead of repeating nm:/Rome for every line, you simply put a semicolon in between, and then you can remove that. So that simplifies it a little bit. So I won't bother to copy and paste that because the result is the same. And each line normally is separated by a period. So to take this a little bit further, suppose we want to get the labels back for Rome, but we want to order them in ascending order. So we can copy and paste this, and using the order by keyword, we can order by ascending and then cast the label as a string, and then get back these labels in alphabetical order. Now, of course, it's sort of Unicode based, so I don't know exactly what the algorithm is for sorting Japanese or Chinese characters after Latin characters, but I guess that's whatever is inherent to the triple store. Oops. So the next query that we want to investigate is, suppose we want to filter and we only want to get the English label back rather than all of the labels. So we can use the filter here and use filter to get the language that matches EN. So in this case we should get only one result back because we only have one English label in the query. Now let's broaden the query a little bit. Up to this point we've only been querying on the predicates and the objects for Rome. But let's extend the query and start to extend the graph a little bit and start to perform queries on all of the mints that we have in Numisma and not just one single mint. So in this case we want to get all of the mints, a variable called mints, where the URI is cast as a class, which is inim mint. And this should give us a much larger list of things. So this is a list of, I don't know how many we have, but it's well over 1,000, I think. So these are all of the URIs that we have for mints. Most of them are Greek, but we will be expanding into other periods eventually. San
That's a list
Francisco.
of all the things that are mints in your triple store.
What was that?
That's a list of all the things that
Yeah,
are mints.
all the URIs that are mints in the triple store. Yeah,
Find all mints.
yeah. Find all mints. And if you wanted to create a map, you could extend that query, as in one of the previous slides, and get the lat and the lon for each mint, and then create a map of it. So, to go a little further, as I was saying, we can get all the mints with this query. We can get the label, but filter for only English labels, get the latitude and the longitude, and get the mint, which is part of the field of Greek numismatics, as we've defined on Numisma. So then we can copy and paste that right in, get the results back, and then we've received exactly what we've asked for, is a bunch of labels with latitude and longitude. And in this case, I'm going to download the CSV, save it to the disk, and then go to View Google Fusion Tables. I don't have the URI or URL for Fusion Tables memorized offhand. I think it's tables.google.com or something, but it redirects you. So I'm going to upload the CSV file that I just downloaded from my SPARQL query. Click Next, and it will confirm that this is the correct format for the CSV, which is true. It will ask me to name the table, which I'm not going to bother to do. And after a few moments, it will create a table for all the Greek mints. There are 1,120 of them. And Fusion Tables is intelligent enough to recognize latitude and longitude, which is very nice, which then allows you to create a map of all of the Greek mints that ever issued coins. There are a few that are misattributed to Greek. These are Roman mints, not Greek ones up in England. But otherwise, you can see the distribution of Greek coin production ranged from Portugal to Pakistan. So it's quite a geographic range. So back to the presentation. Let's dive a little further and start to do some of the queries that are vital to the functionality of ochre and the Roman Republican coinage project. Yeah?
In the previous,
Previous.
what is the previous slide? What is the part of?
Right,
This
okay.
part of-
So Greek underscore numismatics is an ID which is part of a class called Field of Numismatics, and we're using is part of, which is under the Dublin Core Terms ontology, to say that a mint is part of that field of numismatics, which is Greek numismatics. So is part of is probably the most generic way of saying that a concept is part of a broader concept.
Like a subclass.
Right, like a subclass. So eventually we're probably going to use scopes broader and narrower for this. But is part of can have the same basic meaning as that in terms of concepts, but it can also be used, can be applied geographically. So you could say that Rome is part of Italy or something like that. So it can be generally applied to both.
Okay.
So it's very generic.
Thank you.
So so what we want to think about in terms of coin types is that there's a URI for a coin type, and that coin type consists of other URIs that define other attributes of the type, like material, denomination, that sort of thing. So we have, I'm going to switch gears and start to do queries on the Roman Republican coinage simply because we have something like 2,000 coin types but 25,000 coins. So we have much greater coverage in terms of photographs and weights and diameters and fine spot locations for Republican coinage than imperial ones at the moment. So thinking about a coin type as a URI, this particular query will get the objects which are part of this predicate called type series item in our ontology, which are linked to this coin type, which is defined as a URI. And this URI comes from a printed publication from 1974 by a scholar named Michael Crawford, who published a printed corpus of all Republican types. And so we've basically taken his numbering system and then applied URIs to them and providing machine-readable data from those books. Yeah?
Curious whether in your store you have information about that scholar and the fact that he made that classification.
That's a good question. We have to find a URI for RRC. So we have a really basic bibliographic URI with some data on it, but we don't have a lot of data about the people. And I think that's one of the goals that we're going to eventually reach, I think, is better bibliographic modeling and better linking and attribution between typologies and concepts to whatever source produced that concept. Yes?
The point is, the fact that you get it this far along as linked data, somebody else who specializes in what you just described can get those
Mm-hmm.
better, improved, augmented data sets. That's precisely the point.
Yeah.
And typically, the first step that I take in a situation like that is to look to see if that scholar or that system already has an entry on Wikipedia.
Mm-hmm.
And if they do, then you can just manipulate the URL of the Wikipedia URI and then pick up all their data about it and or at least do a see also link, like I see you've already got one up there.
Oh, he's certainly he's probably on Wikipedia, but he's certainly on VIAF as well because he's a published author. So, but we really haven't gotten that far yet. But we do actually have an OCLC, a WorldCat URI for this book, so that's a start anyway, I guess. Yeah, so I'll copy and paste this, and this will show us the URIs that we have that are associated with a particular coin type, which is RRC 273.1 from Michael Crawford's 1974 book. So we do, in fact, have quite a few URIs. Some of them are physical specimens, which are of the coin class. Other records are coin hoard records, which have one or many coin types in them. And then we have some other coins from the American Numismatic Society here, and one from University College Dublin at the bottom there. So they are a recent entrant into our project. So suppose we want to get all of the objects and their weight. So we're going to extend this query just a little bit. And so that will automatically filter out anything that's a hoard because it doesn't have a weight associated with it. So this will show us all of the coins that have weights. But it will also filter out coins, physical objects which don't have a weight associated with them. And I will discuss that a little bit further. So let's say, okay, so we have, I don't know, what is that, 15 maybe? 15 coins, something like that, 20. So let's extend this query a little bit further. And we're asking for a weight and a diameter using the Numisma ontology. So now we have only 4 coins, because what we've done is we've asked for coins that have a weight and a diameter. So by default, joins between lines are and not or. But we can actually use an optional query and only get that information if it exists and still show the URI even if that information isn't available. So this query is like the previous one. We're adding in a title, which is from the Dublin Core Terms ontology, and we're saying that the weight is optional, the diameter is optional, and optionally, if there is a URL for an image using depiction, which is from the friend of a friend ontology, it will then show us a little bit of different information, and it will be a more accurate representation of the number of coins of that particular type in the triple store. So in this case, we have, it's a little difficult to read in text mode maybe, but we have, let's try this. We'll get it in XML, I guess. So we have the URI, a title, a weight, which is a decimal number, and an image, which was pulled from the SPARQL endpoint at the British Museum and stored in this triple store. So if the weight is available, it shows. If the weight is not available, it won't show. Same with the diameter and the image. Now we can also get the average value of something, and this is a feature that we use a lot in Ochre and other projects because it's interesting, I think, and useful to study the ancient economy to look at the change of weight of a coin over time, which is really, really necessary when you want to do an economic study, where you can see during periods of inflation where the weight of a coin is reduced over time because these coins are silver. And so they either make the coin slightly smaller or they debase the coin by putting silver around a core of zinc or some other useless, worthless metal. So in any case, I'll do this query and then maybe I'll do something in the user interface for Ochre, a demonstration which would show how this query can be interpreted into something visual. So we've created an average. So here's the average of 3.83. And basically what we've done here is we've gone back to the query from a few slides before, and we're using average, and we're casting weight, which is the NM weight predicate, casting it as a decimal number, and then calling it average weight as a variable. And so that will give us a number. And we can use this for other sorts of numbers like a diameter or whatnot. So going back to Ochre, suppose we want to observe the change of weight of the Roman imperial denarius from 30 BC to 240 AD and see how it changes over time based on the information that we have in the triple store. So I've gone to the visualize page and gone to measurement analysis, and let's add a query. Let's say we want to observe the coins, which are denarius, and we want to use a duration, say every 10 years from 30 BC to 240 AD, and do a line chart, I guess. And this takes a few moments to spin because it's getting the average number incrementally every 10 years for more than 2 centuries. So what we have, curiously, there must be a lack of data for that. But otherwise, you can see a gradual decline overall in the weight of coins. And after this point, 240 AD, is when the Roman Empire is cast into something called the crisis of the 3rd century, where there were constant usurpers and barbarian invasions and complete inflation of the economy. And if we could extend this graph further, and we will once we go past this point in terms of coin types and data that we've gotten, the weight of the coin is going to dive drastically. So this is just sort of an indication of the types of analyses that numismatic scholars are used to doing. But instead of taking months or God knows how long they would spend in getting this data from all various sources, different museums, different archaeological excavations, hopefully in the future we will be able to have 1 million coins in this system and generate almost instantaneously the types of visualizations that once took many months to put together. So this allows scholars to be a lot more productive in terms of analysis, where they don't have to spend as much time aggregating the data, but they can spend all of their time on the interpretation of the information. So I just have a few more slides to go. We can filter by numbers as well. So if you wanted to get the weights that were greater than 1.7, you can do that by filtering. You can dig a little bit deeper into the graph as we've done here. So we can extend the query and then go through the graph a little bit. So we could, in the first query, this would get all of the types that are silver, which are part of Roman Republican coinage. So that would be most of them, actually. Most of them are silver. So we could take that even further and get all of the silver Republican coins, but then get a list of the actual physical objects that are associated with those types, and I'll limit it to 100, or else you'll end up getting something like 20,000 back. So this is just limited to 100 of coins that are silver. And then we can combine that with union. Let's say we want to get the silver coins and the gold coins. So this is basically identical to the last query, except that we've extended it a bit to include gold coins. And then we can do a little bit more with geography and take the previous one a bit further, get all the silver and gold Republican coins that have a mint, and get the label of the mint, and then get the latitude of the mint and the longitude of the mint, and then get the English label of the mint. So this would allow us to then get a list of mints, which are the mints that issued silver and gold coins during the Roman Republic. Not very many. There would be more if this were the Roman Empire, which I can change RRC to RIC, and we will get a query back, which is a little bit longer. So these were all the Roman imperial mints that issued silver and gold coinage up through the period that we have represented in ochre so far. And then finally, we can get all of the distinct hoards which contain silver and gold coinage and get their geographic information back. So we're getting silver and gold coins that are part of RRC, filter out the objects that are hoards, get the title, the latitude, and the longitude. And so we get quite a list of all the places, all of the hoards in which gold or silver coins were found. We could download this as a CSV file, upload it, re-upload it through Google Fusion Tables. And it will automatically generate for us a map that includes all of those locations of the data we have so far. So, curiously, a large cluster of coin hoards found in Romania. There are many theories about why this is. They seem to have been pretty elegant forgers of Roman coinage, because not all of the coins are actually really minted in Rome, but rather forgeries. And you have to wonder if perhaps that may have been some contributing factor to later military incursions into Dacia, which was the ancient location of Romania. So, finally, there's another filter I wanted to briefly introduce, which is irregular expression filtering. This would allow us, for example, to parse through the grabs for all of these Republican coins and look for the obverse description of a coin that contains Jupiter. we could get find spot information about that, or mint information to see if there's a pattern between where coins that depicted Jupiter were found. Would that correspond to votive offerings at a temple site or something like that? So there are many possibilities, I think, for interpretation. And then finally, you can also filter by date. So this particular query would get all of the coins minted between 100 BC and 50 BC, and then show us the latitude and longitude where those where coins were found. So we could plug that in. And so this will give us all of the hoards that contain coins from 100 to 50 BC, and also the last date of that coin. And so finally, I've put up a few more URLs to look at some further reading. There's a pretty good tutorial on SPARQL on the Jana website, which is a triple store and endpoint software. You can get more detailed stuff from the W3C spec itself. It's pretty complicated, I think. There are a variety of papers that were published following the Linked Ancient World Data Institute, which was an NEH-funded institute the last 2 years, focusing on linked data for the ancient world, as the title implies. And so there are probably more than 20 papers of varying degrees of technicality, so it's a really great way to introduce yourself to linked data in a humanities context. And we have a paper that we published a few years ago on these projects, specifically in the Computer Applications for Archaeology conference. So thank you. I think we have 2 minutes for questions or something like that.
Any questions, maybe?
Yeah. Eric?
This is kind of an academic question, but well, it's a very good example of how you've been able to implement a database type of thing with linked data. Why didn't you do that as a, say, a relational database?
As a relational database? Well, the linking is a lot more sustainable in the long term to use linked data, especially since we're aggregating content from different museums and archaeological databases. So that would just be really, really difficult to do in a relational database model, first and foremost, I think. Yeah.
Can you very briefly talk about what tools and what people you use to pull this off? And by the way, fantastic project. It's so cool to see how sophisticated the projects have become using linked data that are presented here at Semtech. So thank you, it was awesome. But can you tell us about the tools and the people?
Yeah, so Numisma.org was the brainchild of Sebastian Heath, who I think is pretty well known in the digital classicist community. One of the main linked data proselytizers and organizer of the Lottie workshop the last couple of years. Numisma also includes Dan Pett from the Portable Antiquities Scheme in the UK, which is a major archaeological database. It's growing rapidly. And a computer scientist at University of Frankfurt, Karsten Tolle. The development on ochre and the Roman Republican coinage project was done by me for the most part using open source tools. We're using Apache Fuseki as the triple store and endpoint. And we have a variety of JavaScript libraries that we are using to do these charts and mapping and that sort of thing. And most of the back end is XSLT because this is an XML framework entirely. Yeah.
Thank you.
So it's all open source too. Yeah.
I was just wondering if, in this project, if you're recording whether coins were counterfeits, if that was some other bit of information, just, from the graph that you displayed, it really, makes it seem like that there were mints or these coins were found in Romania. If there's a way to sort of show that these are counterfeits of these real coins?
Yeah, at the moment, no, but it's on the agenda. We're working on it in the ontology. Uncertainty is a really big deal for us, and it's not something that's addressed in SIDOC CRM at all. So this is something that we have to deal with on our own entirely. So, but yeah, we will record that sort of information eventually.
You said that you work with aggregated data, right?
Mm-hmm.
How do you manage the synchronizing the data that you brought with the original data?
That's a good question. There's no real workflow for it right now, but I'm working on developing it. A lot of the back-end stuff is done through Xforms, and so that should allow us to pull data dumps from different sources and do updates and that sort of thing. But right now, it's really just me sort of getting dumps from various museums and putting them in through a command line. But that's not sustainable in the long term, but I'm working on enterprise workflows for that.
Okay.
Thanks, Stephen.